हरि करना।
Let's deep dive into the discrete probability distributions. We have seen discrete random variables. Now discrete probability distributions. For distributions, what all we use? So probability mass function, that's one we use. So probability mass function is nothing but so in probability theory, the probability mass function is a function that describes the probability distribution of a discrete random variable. That's what the discrete probability distributions is the one which describe the probability distribution of a discrete random variable. So the PMF assigns a probability to each possible value that the random variable can take on. The probability mass function assigns a probability to each possible value that the random variable can take on. So formally, for a discrete random variable capital X, so if you take capital X, then so but in this case we will take we'll be considering capital Y for a discrete random variable capital Y. So capital Y, so probability of small y is a value. Probability of small y is equals to probability of random variable capital Y at a value small y. So the property is always probability of y is greater than or equals to 1 and it's less than or equals to 1, and then the summation of probabilities of each value of y is 1. So that's what is our these are the properties of probability mass function. So probability mass function, one, for any possible value of small y, for any possible value of small y, the probability assigned by the probability mass function is non-negative, and p of y is equals to p of capital Y is equals to y greater than or equals to 0. That's what we are representing here. And the sum of the probabilities assigned by the probability mass function over all possible values must be equal to 1. That is, sum of p of capital Y is equals to y equal is 1. So if you want to take up an example, we can explain this. For example, let me take this. It's you know this one for us is a probability mass function, or probability mass function comes for discrete distributions, discrete probability distributions. Okay, so let's take an example. Consider a random variable x. Consider a random variable x, capital X, that represents the number of heads in two coin tosses. The possible values of capital X are 0, comma 1 or 2. So the PMF for capital X, because our random variable is X, is P of X. First value is 0. P of X is equals to 0. Then the probability is 1 divided by 4. And probability of capital X, when value is 1, the probability is 1 divided by 2. And probability of random variable X, when value 2 is equal to 1 divided by 4. 1 divided by 4. So The PMF, the probability mass function, assigns a probability of 1 divided by 4 to the value 0. That's the probability of getting no heads in two coin tosses. And second one, a probability of a half to the value 1. That means the probability of getting one head in two coin tosses. And probability of 1 divided by 4 to the value 2. That's the probability of getting two heads in two coin tosses. So the sum of these probabilities is equal to 1 as required. Let's see. So sum of, obviously you'll have a sigma sum of p of x p of x is equals to x for all values. So first one, so this is 2, and this is 1, this is 0. So let me add all of them together. It's 1 divided by 4 plus 1 divided by 2 plus 1 divided by 4. So it's equal to 1 plus it's equals to, so 1 plus p of summation of all is equal to, and it's keep on going, and a few more things to be added, and after adding we should get 1. Okay, so it's equal to, it's 2 by 4 plus 1 divided by 2. So 2 by 4 is again 1 divided by 2 plus 1 divided by 2. That is 2 2 divided by 2. That's equals to 1. Hence proved. So that is your probability mass function, and same thing is applicable for cumulative distribution function. This is pretty straightforward. Similar, we are taking the same example that a discrete random variable is capital Y, and here less than or equals to Y, small y. So capital F of B is equals to P of capital Y less than or equals to B, and is summation of y2 minus infinity p of y, and so it's monotonically increasing in y. So we will see with the picturization, we will visually see cumulative distribution function to get the more clarity. This is the mathematical representation.